A spider always seemed ordinary to me. 8 legs, small body, spins a web. Nothing extraordinary. But the moment I started researching how spiders actually work, that simple image completely collapsed. What I discovered was a creature incredibly advanced, unbelievably efficient, and honestly, deeply strange. Some spiders don't just crawl. The AY travel through the sky, drifting on silk threads like microscopic parachutes. Certain species can even cross vast regions and oceans this way. And the deeper I looked, the more shocking it became. Spiders are over 400 million years old, older than dinosaurs, older than trees, older than flowers, even older than the ecosystems we recognize today. Here's something else many people get wrong. Spiders are not insects. Calling a spider an insect is like calling a human a shark. Spiders belong to an ancient group known as chelicerates, a lineage that split from insects more than 500 million years ago when life was only beginning to explore land. Their distant relatives include scorpions, horseshoe crabs, and ticks. But age alone isn't what makes spiders fascinating. Evolution shaped them into something completely unique, creatures with abilities rarely seen anywhere else in the animal kingdom. So how did spiders become so unusual? What pressures turned ocean-dwelling ancestors into 8-legged engineers? And why did they develop silk, one of nature's most advanced materials, long before webs even existed? To answer that, we need to travel back roughly 400 to 450 million years. During the Silurian and Devonian periods, Earth looked almost unrecognizable. Land was mostly barren, covered in primitive plants. There were no birds, no mammals, and no dinosaurs. Only early arthropods exploring dry ground. Among those pioneers were the ancestors of spiders. These early forms lacked silk glands and venom. They had 8 legs, simple fangs, and bodies originally designed for aquatic life, but now adapting to land. While insects evolved 6 legs and wings, the chelicerate lineage developed differently. 2 main body segments, 8 legs, simple eyes instead of compound eyes, and incredibly sensitive sensory hairs. They relied more on touch and vibration than vision. Spiders evolved before flowers existed, before bees or butterflies. They were among the earliest complex predators on land, hunting in ecosystems dominated by ferns, mosses, and giant arthropods. Early fossils reveal experimental body designs, some with segmented abdomens or short tails, features no longer seen today. Evolution was testing possibilities, but 2 inventions would ultimately define spiders: venom and silk. Venom began not as a weapon, but as a digestive tool. Early enzymes used to break down food internally eventually developed in glands near the fangs. When injected into prey, these enzymes started dissolving tissues externally, essentially pre-digesting meals. Over millions of years, some evolved into neurotoxins capable of paralyzing prey almost instantly. Different spider groups developed different venom formulas. Some targeted insects, others larger animals. Yet most spider venom isn't designed to kill humans. It's designed to liquefy prey, allowing spiders to drink their food as nutrient-rich fluid. Some venoms even act like anesthetics, preventing prey from struggling during digestion. If venom was the weapon, silk became the superpower. Spider silk is stronger than steel by weight and more elastic than rubber. Yet it didn't begin as web material. It first evolved to protect eggs. Over time, spiders discovered new uses: safety lines, burrow reinforcement, and eventually traps. Modern spiders can produce up to 7 different types of silk, each from specialized glands: structural silk, sticky capture silk, wrapping silk, and more. Some species push silk engineering to extremes. Golden orb weavers produce glowing golden webs. Darwin's bark spiders create incredibly tough webs spanning entire rivers. Bolas spiders swing sticky silk like lassos, while diving bell spiders construct underwater air chambers. Perhaps the most extraordinary function of silk is sensory. A web is not just a trap, it's an extension of a spider's nervous system. Vibrations traveling through silk allow spiders to identify prey type, size, and movement patterns even in total darkness. Many orb-weaving spiders rebuild their webs daily, recycling old silk proteins and constructing fresh structures optimized for current conditions. The web becomes a temporary sensory network, a physical extension of perception. Yet spiders themselves are just as remarkable. Jumping spiders possess telescopic retinas that scan environments internally, allowing advanced depth perception and ultraviolet vision. They can leap distances up to 50 times their body length. Their legs function hydraulically, using internal fluid pressure rather than muscles to extend. When that pressure fails, legs curl inward, the reason dead spiders appear curled up. Thousands of sensory hairs detect tiny air movements, vibrations, and even sound waves. Some spiders can sense wing beats before prey even touches their webs. Hunting strategies vary wildly. Trapdoor spiders ambush from underground. Net-casting spiders throw silk nets in darkness. Crab spiders change color to blend with flowers. Some species mimic ants to infiltrate colonies. Even more surprising, certain jumping spiders demonstrate planning behavior, scouting prey, analyzing web structures, and approaching from strategic angles. Despite brains smaller than a poppy seed, they display complex problem-solving abilities. Spider intelligence may not resemble ours. Instead of centralized thinking, their cognition may be distributed across sensory systems, body mechanics, and environmental structures like webs, and evolution is still happening today. Urban environments create new challenges and opportunities. Some spiders now build webs near artificial lights to capture insects. Others adapt to indoor life, thriving alongside humans. Climate change is shifting ranges and reshaping predator-prey relationships worldwide. Spiders have survived mass extinctions, ice ages, asteroid impacts, and volcanic catastrophes. Long after many species vanished, spiders endured. And chances are, they will continue long after us. Right now, the goal is to push storytelling and production quality further. Stronger visuals, deeper research, and more immersive narratives. If you enjoy these films and want to see even bigger projects in the future, your support truly makes a difference. And until next time, there's another story waiting for you.